And hello, everyone. My name is Gregory Green. It's a privilege and an honor with you to be with you today. Arnab, if you wanted to say hello.
Hey, hello everyone. Arnab Chakraborty this side. I take care of product marketing for Tanzu Data Intelligence. And with that, let me hand it back to Greg to start this webinar.
Okay, great. And I have the privilege to working with our many financial customers. I specialize in our data products. So telling the story of how our data products can be used for various use cases, in particular artificial intelligence in the financial sector, is really our main goal for today. So we have a mix of showing you explaining some benefits and showing you some demos. But let's just dive right into it. So when Arnab and I were planning out this webinar, we thought it was important for us to kind of explain the timeline of how technology has helped to evolve data intelligence, especially in the financial sector. Now, I do not have the honor of my career does not span this entire timeline. I really started my career in the 90s and in the late 90s. And I remember during that time was the dot-com boom, where there's lots of excitement about the internet. And researchers were saying that every corporation was going to be doing their business over the internet using things like the browser. Now, if you remember, if you're old enough to remember that time, it took a while for that dream and that excitement to be realized. But now today, absolutely, we see it, right? So I imagine you are like me, where you probably do the majority of your financial transactions over the internet, right? I can't remember the last time I've been in a physical bank because through a web browser and even through a mobile app, you can just accomplish so much. And now that we're in this data intelligence age where we're talking about AI, whether it's generative AI or agentic AI, or not, we were talking about this, how artificial intelligence is not new, right? Artificial intelligence was first introduced in the 50s, but now over time, it's just been easier and easier to incorporate into our everyday lives. And all of these technologies, they kind of piggyback on each other. So, for example, online banking, it's built on global payments, where in the 80s you introduced things like message-oriented middleware that's built on top of mainframe computers, mainframe computing with programming languages like COBOL, and that's built on top of ATMs that were developed in the 60s. So over time, it's just making things easier, easier, easier to use. Now, I really feel like we're at the beginning of this data intelligence era where generative AI and agentic AI, there are a lot of excitement, and there are some customers that have been able to take advantage of that. But I would say that there's more room for adoption and growth into this area, and this is where we want to spend a little bit of time to talk about during this webinar. And I'll let Arnav speak to this slide.
Thanks, Greg. Um, so, Greg, you just covered the timeline of how intelligence has evolved in the financial services industry, right? But if you can just step out of the history books and then come to the present and talk about how CIOs at these or the CXOs at these leading organizations, financial services organizations, how what they are looking at and how where exactly they are standing right now. So on the first pillar that you see over there, you'll hear that a lot of these CXOs are facing a lot of pressure from the board that they are looking at all these infrastructure upgrades and AI spends. It should lead to top line revenue growth, right? They don't just want IT projects, but they actually want core business outcomes. Um, but a lot of the data engines that they have within the organization, they're legacy engines. A lot of them are decades old. So it's a lot like changing the engine of a jet when you're flying at like 35,000 feet. It's not that easy. Secondly, the velocity of data is changing, right? There are multiple customer and operational touch points across which data is getting generated. And all these legacy anchors, they can actually lead to a lot of bottlenecks in the pipelines, right? So your ability to make sub-millisecond decisions, that gets impacted. The third is that everyone wants the magic of agentic AI, but as we try to scale or even start these projects and then scale it, we are running into some kind of a cloud trap, which is like, you do not have any predictability in terms of costs, what the costs are going to be in the future, how the economics of scale are going to work out, when you're trying to do this across the enterprise. That's something that is a black box right now. And the last aspect of it is the sovereignty and security aspect, right? With the advent of these modern AI models, you are not just fighting the traditional hackers, right? We are actually defending our perimeters against AI-backed, AI-accelerated threats. And to fight them, fight these at machine speeds, you actually need to build defenses that can work at machine speeds, right? It becomes really important. If we go on to the next slide, this is exactly what Tanzu Data Intelligence solves, right? Now, this as an architecture allows you to innovate on top of your proprietary data in a highly secure AI-ready environment, right? On top of your private assets. So if I can take you through this architecture, at the core of this, you'll have VMware Cloud Foundation, right? That's at the very bottom. So if you look at the very base of the slide, VMware Cloud Foundation becomes really important for a financial institution. Why is that? Because the entire data infrastructure is actually deployed inside your own secure, sovereign, private cloud environment, right? So you do not have to worry about anything going out. On the far left, you see the kind of input pipelines which are there, right? You can actually pull anything from market feeds to legacy source systems, IoT telemetry, system logs, all the different kinds of files that you might have in your environment. And Tanzu Data Intelligence helps you absorb all these chaotic data points that are there and act as a single intake layer for the entire organization. And then in the middle, you have five central pillars. You have data sourcing, which means you can actually orchestrate all these complex pipelines all together. Then you have storage and compute. You have basically you have massively parallel processing Lakehouse foundation. So now you do not have to worry about your infrastructure stopping when you're running heavy workloads. Then you have data quality and governance, which means that we actually were speaking about quality and governance issues in the past, right? So here is where you get automated metadata tracking. Then you have business analytics and AI ML, which is the output of this. You can actually work on petabytes of data without having to worry about the scalability of the amount of data that you have. And finally, you have real time, right? The real time aspect of it is brought about by the in-memory techniques that we have, the platform that we have. We ensure that when the market events are actually happening, you can actually process them at sub-millisecond speeds. So when you bring all these things together, and because this foundation is clean and governed and fast, you can have all those outputs that you see on the right hand side, the multiple consumption options that you have without having to worry about, any points of failure or anything to do with scalability issues. Moving on to the next slide, I just wanted to double click on the aspect of vSAN. This is a more complete architecture of how Tanzu data intelligence works really well with vSAN. Now, running TDI on vSAN actually provides multiple different advantages over, assembling different disparate infrastructure, right? The first thing is the AI, vSAN almost delivers up to 300,000 IOPS per node. And we know that data ingestion and vector retrieval they need for AI use cases, they need massive throughput. And this scale of vSAN ensures that your AI agents do not really have to wait on disk latency when you're meeting real-time conditions. The second aspect of running really well with vSAN is that it's integrated really well with the VCF infrastructure stack, and because of which it delivers almost a 39% lower storage total cost of ownership as compared to traditional or siloed storage arrays. And the third is, testing of agentic AI actually needs production grade data, right? You cannot really work on any other data, but you actually need production grade data. So vSAN actually provides native snapshots abilities, which allows these data teams to efficiently clone massive data sets for development and test them without having duplicate storage capacity or impact your production performance. So all these things make this Tanzu Data Intelligence on vSAN and VCF a complete data platform for your use cases, for your financial services organizations. Moving on to the next slide, I'd like to cover what are the 5 key pillars which are really important that we provide from Tanzu Data Intelligence that we provide for financial services organizations. The first one is the real-time data mastery. We specialize in working on real-time data, how to ingest, how to handle them, how to handle them at high velocity, low latency, all these aspects. The second aspect is how to democratize AI within your organization. We are working rapidly towards it, and we'll show some demos as well as to how we provide this. The third aspect, obviously, because we are a private secure infrastructure, how security is very important for us, and given the governance standards that financial services organizations have to provide, this becomes really important. The fourth pillar is how can you have audit ready capabilities for anything that happens in the future? How do you have secure lineage and these kind of capabilities? And the fourth aspect, which I was mentioning in terms of in-memory capabilities, is how can you eliminate any sorts of bottlenecks and ensure that there is low latency for any kind of real-time data processing that you need. So based on these 5, we are going to talk about these more in detail. With that, let me hand it over to Greg, back to you for the demos.
All right, great. Thank you, Arnav. So as we discussed, I personally wanted to build a solution to help me in my own trading recommendations. So I thank you for the invite because I have really fun to build this demo. So this demo is an agentic workflow example where I have various apps. So I have an agent that will can automate autonomously pull stock news information and determine the sentiment, whether stock news is bullish or bearish. If you're not familiar with that, I wasn't familiar with that. I had to look it up. Bullish basically means it's a positive sentiment that you should invest in the stock, and that's bullish, and bearish is the opposite, right? It's pessimistic, concerns about the stock, so on and so forth. Now, this pushes the output to another agent, so which may use, all of these agents are using large language models. In this case, this trader agent will take the output of the sentiment and determine, based on its model and its data, like pricing information, whether you should buy or sell the stock and what price you should buy and sell before it pushes to a third agent that determines the risk. Now, I thought something like this was important because whenever you're thinking you're building a solution that involves generative or agentic AI, you got to know that these large language models are non-deterministic, meaning you ask them a question, the same question, it might get 2 different results, or it may hallucinate or just make up an answer, right? So again, in this example, I'm not just relying on one model and one agent. There's certainly multiple redundant checks to validate the output of one agent before passing it to another. And I also thought it was important to add a sort of a human in the loop, especially for some high risk financial use cases where, again, like trading of a stock can involve a significant amount of money, right? So you probably want to have someone to do one final check before executing a trade of potentially millions of dollars. But I think in general, especially again for these agentic workflows, um, people are going to be doing less coding. Like these demos that we written, most of it was coded by large language models. So I think we're gonna see more and more of developers doing less development and more people doing supervising, tweaking the output to make sure that these large language models are more deterministic, more reliable in terms of their output. Now, I am a huge Spring Java ecosystem fan. So all of the agentic apps were written using Spring, and in particular Spring AI, which is a beautiful abstraction layer. I know we're talking about data, right? But in the Spring ecosystem, right, these Spring projects just makes it really easy to incorporate our various data services. For example, our in-memory solutions like Valkey and GemFire, and also Greenplum. I thought it was important to include something like Greenplum because think about determining the risk that for a trade that a portfolio agent might use, right? You want to be able to determine the risk based on historic data, right? So storing large amounts of data is a perfect use case for something like Greenplum. And also everything is orchestrated by another one of our products, which is called Tanzu Data Flow. So let's actually jump to a recorded demo. So in this case, showing the power of using, this is Tanzu Data Flow, which is based on Spring Cloud Data Flow, and it allows you to to launch or manage task or batch-based jobs. So you register, first of all, you register these apps with the platform. Once you register an app as a task, you can basically have this very easy to use interface in order to define the execution of a task and provided runtime arguments, like in this case, the location of a file to load end of the day or start of the day stock prices information into a data repository. One thing that's really nice about this interface is, again, you can get insights into all of the configurations. You can change all of the configurations. And when it deploys to containerized environments. Like we have Tanzu platform based on containers. And then we also have VKS that can run inside of vSAN. Now, what this is showing is this is going to load data into GemFire. GemFire is an in-memory solution. You have these notions of regions, which are like tables in a relational database. This is where we're going to store the stock price, the daily stock price information into GemFire. So GemFire, it's a key value store-based data store, but also it can store structured data that can be visualized very easily, can be queried. So again, this task, it loaded about 1 million stock price information into GemFire. And again, what I really like about Tanzu Data Flow is, again, you can get insights into the execution of this job, and also you can look at the log files. So if there's any issues, again, whether this is running on Tanzu platform, on VKS, on any flavor of Kubernetes, you get the same experience to manage, provision, configure this. Now, this is going back to GemFire. So the GemFire in particular, let me quote this right here. GemFire it's a distributed in-memory solution, right? So again, there are 2 servers. So the job basically loaded data sets into, tried to evenly distribute the data across multiple servers, right? So again, you get the insights into running batch jobs, because I think batch or short-lived processes will always have a space and a spot for data processing. The next thing we wanted to show you is, go back to slideshow mode. Now this is going into long-lived applications. So think about an agent. An agent is something that is maybe a process that's always running, waiting for events or waiting for API calls. So you can deploy something like an agent also using Tanzu Data Flow. So you just register it as a container or as in some sort of application, like a Java application or Python scripting app that can be turned into a Docker container. Once you have that register, again, you can just deploy it using a really easy to use interface. Once you create the app and you deploy the app, and you can provide runtime configuration, right? So it gives the status of the deployment of the stream. You get a visualization of the stream. So in this case, I deployed 2 supporting apps, and you get insights into the logs of these applications. So again, if there was any issues, you get a visualization of the app. Again, insights into all of the configurations, the logs. So again, I am a big fan of this particular product, Tanzu Data Flow, just to get, not to just manage it, not to just deploy it, I should say, but also to manage these applications. All right, so now for this particular flow, the next demo we're going to show you is actually deploy these apps and exposing an endpoint, HTTP endpoint, to be able to utilize these apps. So in this case, this is the first agent. So this is the new sentiment agent. Again, what it's doing just for demo purposes, it generates random news about fictitious corporations. But again, it's determining the sentiment, whether it's bullish or bearish, using a large language model. So in this case, the first agent is using the Llama model. This second agent, this is using the minstrel outputs right here. So again, the first agent, this is the input that came into this portfolio agent. So this agent is using, again, that agent used the Llama 3. It determined whether this was a neutral. It wasn't able to determine whether it was bearish or bullish. And this agent, again, especially because the sentiment in this case, it couldn't determine the sentiment. It couldn't determine whether it should buy or trade this stock, I should say. So again, multiple layers of redundancy using different models, whether it's the Mistral model or the Llama model, but all powered by Spring AI for this particular workload. All right, so continuing on in the demo. So it was able to recommend a buy for at least one stock. So you see, example, this was a bullish sentiment, which resulted in an output of buy, right? And then think one thing that was also important for me for this particular workflow. So you can see within these apps, you can see each step from the news sentiment to the trading recommendation to the portfolio agent. So the portfolio trading agent, right, this only gets valid output. So in this case, it got the one buy recommendation from the trader resource agent. And again, you see the entire flow. And in this case, this agent is using the GPT-based model. So again, just another model. And again, the story here is, again, you don't have to rely on one model, put all your chips, so to speak, in one model. You can have different models that kind of validate each other. And there was another recommendation because, again, the news sentiment is real time. So it's constantly generating new news, and the communication between each one of these agents is using RabbitMQ under the covers. The next thing I want to do is talk about like our in-memory capabilities. So going back to the news sentiment application, this is using our in-memory solution as a vector database. And you have the option of using your Valkey or GemFire. In this case, we're using Valkey. So I'll just say in general, this demo was recorded on a server that just had a CPU, right? So if you have any experience as you start exploring these agentic or generative AI use cases, you'll know that asking a question to a model that's just running CPU, it can be slow, right? In this case, asking a question about determining the sentiment of this news, this took about 34 seconds to respond to get an answer, right? Which is again, if everything in these demos is asynchronous, but when you have a blocking based experience, right, waiting for 34 seconds is painful. But what you could do is you can basically use these in-memory solutions as a semantic layer for semantic caching. So in this case, what we're doing is this is something a supervisor may do. So adding some domain knowledge to say that anytime the news has anything about stock manipulation, then you should return a deterministic response that says that this is bearish and that basically it can't be trusted. So if we were able to we do this again, test this in this case, I'll pause it right here. So in this case, it's a different stock, but the sentiment is very similar, not using the exact words that were used for the context, but using similar words. That's how it's able to tap into the similarity search, and it's doing everything in memory. So you still have to use a model to convert this context into a numerical form, because again, even doing semantic search is all based on numerical output. But again, the result is much faster. So in this example, if I click continue, in this example, you were able to go from 34 seconds to 6 seconds, which is a huge performance improvement, right? And you can do it once you start using these in-memory solutions. This next demo is that was using Valkey. This is basically using. I'm going to actually slow this down and I'm going to back up a little bit. So in this example, I'm using GemFire. Okay, so GemFire for these stock trading recommendations, you'll see that the large language model, the Mistral model in particular, wasn't able to recommend a trade, an execution for some of these stocks, right? But what the solution does, it adds these stocks that it wasn't able to provide a recommendation on, it adds it to a watch list. And in GemFire has something called a continuous query. A continuous query is basically you'll see these at the top. This is basically just a SQL statement. But what's different about these is that you're registering this SQL statement with GemFire itself. So anytime data comes in real time that matches these conditions, my code will be executed. So again, I can specify whenever I want to automate the execution of a buy or execution of a sell, I can express all of those using a SQL statement. Because again, so as data is coming, in a stream of data is coming in, I don't have to poll that data. GemFire is going to push that changes to my app, and then in real time, I can execute either a buy or a trade. So in this case, we're changing the stock price above the 200-day moving average. So that is basically going to result in a buy of this Acme Telco app. Great. All right. So the next demo is basically now the portfolio trading agent. This is using Greenplum, right? Again, Greenplum is a massively parallel processor database. It's based on Postgres, so my Spring application it just looked like Postgres. But Greenplum has an MPC-based server, but I wrote my own MCP-based server, which basically allows me to use natural language process. This MPC-based server is managed by Tanzu Dataflow. So I can see, I'm going to pause this. So in this case, it took the natural language, gave it to a model, and it produced SQL. And the SQL is ran against Greenplum, and the results are actually converted to a map, and the format and it formats HTML to return back to the app, all using a large language model. So again, I think this is one of the reasons why things like generative AI and agentic AI are so exciting because now I don't have to be a data scientist to use a model, to use like the deep learning models or just classic models. I can use natural language processing in order to do, pretty complex, sometimes can be potentially complex things, like, for example, determine the top stock prices, top three, highest prices, lowest prices, so on and so forth, right? So you don't even need to know SQL, right? You're just doing this using a large language model. Now, I will say again, remember, I said that these models are non-deterministic. So in this example, it actually gave me an error, right? Because again, it didn't fully understand the question, so it produced invalid SQL, right? So again, but since it's non-deterministic, if I just try it again, it was able to execute this particular SQL. So this is just it also points to the fact that you have to give these models as parameters, guardrails, and accurate data so it can produce consistent, accurate outcomes. All right, that's the end of these demos. I'm going to hand it over to Arnav to talk about this slide.
Thanks, Greg. So all of you saw we just covered the first pillar of the five pillars that we had of how Tanzu Data Intelligence can help financial services. Now, the other pillar that we have is democratizing AI and analytics access. We know that companies are pouring millions of dollars into AI, right? But the frontline workers, the people who are actually driving the business, they are still not feeling the impact. Sometimes they are bottlenecked by, say, maybe the IT teams have still to write, complex SQL queries to pull a basic report. That is the power that they want to have with them. On the other hand, there can be, the skilled DBA headcounts are not increasing at the same rate at which, the agentic use cases are increasing. So how can we help them? How do we make AI work for these sets of people? Now, just for that, we have a demo right after this, which talks about how we can help. Now, we have something called SQL Assistant for Tanzu Data Intelligence, which is a new tool which helps you interact with your proprietary data, your data estate in natural language. It's not just a chatbot, it's a deeply integrated, very context-aware tool. It actually can link with any of your open model. So here you see there are here we are taking example of a retail demo. So you have all the different aspects of a retail demo which are there, right? Like customer and what is the churn report, etc. Now, if you have to go through a specific column in the report, we don't have to go through the entire table. Here you can see you can just give the query and it actually helps find out which column that is that you need to look into. Then if you want to combine something like a subtotal and total amount, you can, if you want specific business questions, it's able to understand the math behind it. So you don't really have to work on going through multiple tables to understand it, right? As an example, I'll also show you how you can actually find out customer lifetime value. So you basically have to, so if you saw the demo, you had to work on joins across customer and order history. And also through various revenue reports. If you combine all these things, SQL Assistant can actually help you do performance improvement as well and improvise your query. So basically, you are able to provide to the entire organization in different departments this power of SQL Assistant, which can work on your proprietary data, not having to worry about the complicated models behind it. Um, we can go on to the next slide, please. Right. Sorry, my screen. Okay. Yeah. Yeah. So we spoke about how security is becoming really important in this AI accelerated uh, environment, right? So what are the ways in which we are reacting, right? Firstly, traditional static analytics analysis is not no longer going to cut it. So what we have to work on is advanced. We have to work through advanced AI frontier models, and that is what we are doing in our continuous code review to find out the issues which are there. Secondly, we are proactively using the same models to aggressively hunt for the vulnerabilities which are existing in our own code bases so that we can fix them. Thirdly, we know that the vulnerability disclosure and exploitation timeline, the gap in between these have actually reduced from weeks to almost real time right now. So from when the issues get reported to when the issue, the vulnerability is actually happening, that timeline has really come down. So we need to instantly reproduce these, report these, identify all these software versions that are getting impacted due to this, and draft code fixes for each of these. Lastly, we have 24 by 7 global security team for all of you, which can help with any other issues that arise in terms of these AI assisted vulnerabilities which are taking place. If you go on to the next slide.
Yeah,
Yeah,
I can
Greg,
cover
why don't
this.
you go through? Yeah.
Yes, yes, yes. All right. So piggybacking what Arnav said, especially around security, what I wanted to share is that our customers are using our data products like GemFire, like Rabbit, like Greenplum, in very highly regulated environments, and they've been using these products for many years. So that just speaks to how these products are trusted even in highly regulated environments where you can deploy them on platforms like VCF or Tanzu platform or even Kubernetes, where we have operators. We use the operator pattern in Kubernetes that can run on VKS. We have a tile that can automate the security of these data pipe services running on Tanzu platform, and they support either native encryption of data, or you can utilize infrastructure level encryption using things like vSphere, and backed by our support team for 24 by 7 support. For optimizing sovereign security, the point here is, again, you don't have to utilize public offerings, especially if you are looking for vector databases to store your domain knowledge so that your models can be more deterministic. You can utilize trusted data services, like, for example, Postgres. You can use our version of Postgres as a vector database. I already showed you how you can use GemFire and Valkey as a vector database, but also Greenplum can be used as a vector database to manage your data, your secure data privately. And in particular, GemFire and Greenplum is closed source. So that's beneficial because public open source data services that are not backed by major technology companies, they are highly vulnerable to the zero-day vulnerabilities where, again, these hackers have powerful large language models where, again, they're able to look at the public announcements of a vulnerability and quickly expose them in open source solutions, right? But things like Greenplum and GemFire, they are closed source, and the vulnerabilities and the patches are safely and securely communicated and shared with our customers. For disaster recovery, again, I'll just say that we just optimize replicating data across different sites. So, for example, there's intelligence built into technologies like GemFire, Greenplum, and of course RabbitMQ, because RabbitMQ does everything in terms of data movement. Where you're not just replicating full data sets, you can replicate just things that change, and you can pick and choose what data set that you want to replicate, and the data can be sent in a compact or compressed manner. And you can store backup data, whether that's in Greenplum, Valkey, or Postgres, into a S3 storage. So again, in that way, you can have multiple copies of that data in S3 replicated across multiple sites. So the time to recover, God forbid, in the case of an emergency, will be easier using these technologies and using this automation that's built into our data services. Arnab, pass back to you.
Yeah. Yeah. Now, the next pillar that we had, which was on audit trails, very important for a financial services industry, right? The first aspect is that of data lineage. You need to have the ability to trace the exact journey of your data. If, say, a model is taking a particular credit decision, you need to be able to later on find out which exact data set did the AI model look for at that specific microsecond, right? So that's the kind of lineage that you need. Then comes the aspect of security auditing. You need to have continuous flow of tamper-proof records. Whenever the AI agents start acting autonomously, you have to log exactly who, whether it was a human or a non-human agent, accessed, queried, altered any kind of data. So that's the kind of audit-proof resilience that you need across your organization. Now over to Greg. Let's play this Wimbledon between you and me so that you can go through what we provide. Yeah.
Yes, sir. Yes, sir. So some technical details around audit trail requirements. First of all, in the demo, as I mentioned, I'm using Greenplum for the portfolio agent because Greenplum is able to scale to maintain and manage potentially large data sets, right? Again, you can keep data since the beginning of a system, historical data, right? So, and as you have more and more data, you can essentially just add more and more servers to manage that data. In addition, you can use Tanzu Data Lake. So Tanzu Data Lake is a collection of open source products. In particular, everything that's in the Hadoop ecosystem, like Hive, like HDFS, like MapReduce based solutions. Again, that's covered. We provide support for that, which is big because, again, big data or large data sets was one of those technology booms previously, and a lot of our financial customers have invested in things like Hadoop, and now you can get support for us, but also Greenplum integrates out of the box with Tanzu Data Lake. So for example, you're able to perform a query to query data that's in HDFS, for example. And also, when in the demo, as I showed, each one of the events with each one of the agents is managed by RabbitMQ. RabbitMQ has a newer feature called streams, so you can treat every message as an immutable event. I'm gonna go ahead and open up. This is a view of the RabbitMQ, the Tanzu RabbitMQ management console, and it has an extension where, again, if I want to look at all of the events that were entered into the news agent, I now have this nice browser where each one of those events, it has an offset. I can look at the various offsets based on dates and times. If I wanted to look at the details of those events, I could just click on the particular records. So again, now you have insights into all of the events that were shared across the various agents. So again, if you wanted to see the details at any point in time, the inputs and outputs of any one of these data sets, you can use something like the RabbitMQ management console. And also for data lineage, right? We showed you in the demo how Tanzu Data Flow, it does provide some data lineage. For example, looking at the history of all of your batch jobs that were executed, and also showing a visualization of not only your tasks, but also your streaming, your long running agentic apps, but also within the Tanzu Data Lake ecosystem of open source solutions, we have something called open metadata, which is another very powerful tool that provides not only lineage, but data governance. So you could do things like, for example, defining SQL expressions that make sure that your data is clean as it comes into maybe Tanzu Data Lake or into Greenplum, so on and so forth. Now let you take
Awesome.
this one, sir.
Yeah. So with this, we go to the next pillar, which is why we need massive scale speed when it comes to financial services and its transactions. Now, let me give you an example. Let's say you're dealing with millions of concurrent event streams, right? Like global. So if there is a company which has global footprint, it will have multiple point of sale swipes across the globe. You'll have IoT telemetry, or let's say another company might have live trading feeds. Now you cannot dump all these large scale traffic directly onto your old core banking systems. They will collapse under the weight, right? Also, the transaction window for, let's say, a modern credit card swipe, a digital payment, or a high frequency trade, it's extremely narrow. So unless your platform is able to take these things on the go, analyze these petabytes of data on the go, and work on with historical, let's say, risk signal models, so that you can find a fraudulent transaction. Unless you are able to do that, maybe you have already cleared a fraudulent transaction in front of you and you're not even aware of it. So that's why it becomes really important, and which is where Greg is going to explain the in-memory data grid and distributed caching capabilities that we have on the next slide.
Yes, sir. And I think that anytime you talk about real-time based systems, uh, managing data in memory is extremely important, right? Because data access for data in memory is much faster than accessing data on disk, right? So for our in-memory solutions, you have the option of using Valkey and GemFire, as we showed in the demo. Valkey can be used for relatively simple operations, but it also can be used as a vector database. But GemFire can also be used for simple use cases, but it also can be used for more advanced use cases. Because one of the key differences with GemFire, it supports strong consistency, meaning that every record that you read is a record that you actually wrote, even when GemFire is distributed across multiple servers, which there is not many in-memory solutions that support strong consistency. And also, you can scale GemFire vertically, horizontally by providing more CPU cores or deploying it across multiple servers and utilizing its distributed compute capabilities. So if you remember during the demo, I talked about something about the 200-day moving average, things like that. You just write a GemFire function that you push your logic onto the grid itself and it's executing where the data is at scale, in addition to being used as a vector database. Now, some use cases we want to try to run through is first fraud detection, right? So with fraud detection, really our superpower in the AI world, as I mentioned before, is Spring AI. Now I know Python is very popular, but not. I haven't seen our customers using Python for real-time based mission critical systems. So again, bringing the power of AI to the Java world to do event processing, and that you can also utilize event processing with technologies like RabbitMQ. You can store data that can help with real-time inferencing into an in-memory solution. And also, you can do things like, for example, classic models. So imagine you have a classification model that's using smaller frame or smaller formats like Onyx, where the model is actually managed in megabytes. You can actually push that to the cache and basically push that closer and closer to where the applications actual execute the detection. And then you could also continuously update the cache by having your AI pipeline that may use large language models that fine tune the smaller language models and utilize larger data sets that may be managed and in the combination of Greenplum and Tanzu Data Lake. One more use case is customer intelligence. Think about like exposing a chatbot to an end user, but giving it the power to be able to give it more and more data. And maybe there is the data coming from various systems, and you can orchestrate those APIs or those data pipelines, real-time data pipelines using data flow, or within the Tanzu Data Lake, we also have Airflow, which is another batch-based, orchestration-based solution, in addition to Apache Spark, which is also in Tanzu Data Lake. And you can implement a medallion architecture where you have your raw data that's maybe stored in Tanzu Data Lake, maybe stored also in an S3 storage, maybe backed by vSAN. You have filtered or curated data that's stored in Greenplum that pushes it out to operational data stores that's backed by Postgres, MySQL, or GemFire, that where you expose APIs, maybe that are written in Spring, but also you can maybe stream that data using data as a product using RabbitMQ streaming technology. So it's a lot of options that you have here. Now, just to recap, as we start to wrap this up, again, you can use our data products for retrieval augmented generation, right? So remember the semantic search example where you were adding context to the in-memory solution to make sure that the models are more deterministic. You can utilize pipelines to make sure that the vector databases are up to date. You can use the in-memory processing power to make sure that everything can be more real-time and more responsive. You can orchestrate your data, your agentic workflows using technologies like Tanzu Dataflow that orchestrates either Spring AI-based applications or even Python-based applications that are containerized running on VKS or Tanzu platform. You can use Greenplum, which we don't really have time to go into, but Greenplum is sort of like its own ecosystem in itself. Arnav talked about the ability to use natural language processing in order to do a query, but also you can run inferencing and training native within Greenplum, in addition to using its MCP-based server to not only perform queries, but also inquiry about the health of your database itself.
All right, now let's jump directly into what we have done. So a lot of what we spoke, these are not just theoretical. We have active production scale customer engagements across each of these categories that we have highlighted here. We have highlighted 5 critical high value use cases that we generally hear from our customers a lot across anomaly detection, business intelligence, real-time analytics, regulatory reporting, and AI agent frameworks, right? These are the areas around which we hear a lot of buzz. Let's jump directly into the case studies. Greg, maybe you can take the first one while I take the second.
Yes, so the first case study is all about our in-memory solution. So for example, oh, sorry about that. Um, for example, many of our customers are using GemFire for real-time transactions and real-time payments. This customer in particular, before GemFire, they weren't able to get consistent low latency at scale. So again, because of the things that I talked about, how GemFire you can scale across multiple servers, it supports strong consistency, which is critical for things like payments. You can throw more and more cores at GemFire because it's multi-threaded. Now they were able to consistently get the low latency that they needed for real-time payments. And Arnav, you want to talk about this?
Yeah, this case study is United States Senate Federal Credit Union. Now, as you can see, the nature is highly sensitive in terms of the kind of membership data that this credit union commits to, right? So it needs to commit to keeping all its workloads on the private cloud. But the legacy setup that it had, it actually lagged in the elasticity which is needed to handle the kind of the scale of data which is there, right? And during peak workloads, there used to be a lot of issues, which is where they actually started moving towards VMware Tanzu Greenplum as their foundational enterprise-ready data warehouse. Once they started using this, they were now able to have the flexibility of getting or expanding into unstructured data processing as well. Now, slowly and slowly, their data strategy has now matured. Now they can analyze application logs, loan documents, PDFs, and there are multiple different use cases which are coming out of this. So Tanzu Data Intelligence is at the core of, along with VCF, is at the core of the transformation which is happening at USS FCU. Maybe we go on to the next slide and summarize that, how leading firms in the financial services or elsewhere as well, what they are doing differently and how maybe you can take the next step, right? So the first shift that we see is that it's a cultural shift that um, firms have started treating data as an asset and not just a byproduct, right? So they want to unify the different sources of data that are there and make it highly accessible. Secondly, before chasing disconnected AI pilots, they want to actually future-proof their core architecture, the data architecture. And they have a lot of emphasis on data privacy and sovereignty. That becomes really important for them. Thirdly, they want to combine all kinds of raw, structured, unstructured, semi-structured data, using, let's say, governed vector querying, so that AI agents can accurately interpret the context around which the data is actually getting gathered over there. And lastly, uh, they want to prioritize on AI initiatives which actually drive meaningful impact, not just for the sake of doing it, but which are measurable, which can actually accelerate their business outcomes, analytics, such as real-time threat detection in case of financial services, etc. So, Greg, why don't you cover what are the steps which customers can take, how they can engage with us, so that they can understand more about what we can do.
Yeah, so I'll just say in general, because we're kind of running out of time, that reach out to us. We would love to do a discovery to figure out what are your pain points. And we have lots of material, lots of workshops, hands-on workshops, where we can help you to realize a lot of the things that we had in the demo, how you can realize this in your current systems to solve either your generative, agentic, or basic data intelligence challenges. So I think that's it. Arnav or AJ, you want to wrap us up?
Yeah, sounds good. Thank you, Greg. Thank you, Arnav, for today's presentation. In case there's more that you guys would like to learn, well, first we can bring Greg and Arnav back for a second webinar. But until then, there are a few resources that we have available for you guys, some blogs, a recording of a previous webinar taking place in May that you guys can view at your convenience. We did put some of the links in the resources tab below. We will also include this in the post-event email, the links that you see here on screen, as well as the recording from today's webinar. We did have a question. Not sure if you guys have a minute to take this. Is that all right to read that out loud? So
Yes.
we have a question here. Market and trading data can be massive and can change frequently. Can you share how GemFire can handle such workloads?
Yes. So what GemFire allows you to do is, first of all, it's stored on the JVM. There's no real data restrictions. And a lot of the JVMs nowadays, we have some of our customers that are scaling a single JVM to a terabyte in size. So we got, for example, some customers that have hundreds of GemFire servers. Each one of those servers are a terabyte in size. So you can really scale to larger data sets all in memory using technologies like GemFire, and GemFire supports things like partitioning. So again, as you have more and more servers, you can have more and more data, but also it supports things like eviction. So for example, maybe you only want to keep a certain window of data, maybe data for a week or for a month, so on and so forth, and you can evict all of the historical data sets. You can manage all of that using GemFire's eviction capabilities. GemFire also has the ability so suppose if you're only keeping a finite amount of data, maybe you want the historical data stored in Greenplum. There's a GemFire and Greenplum connector where you can basically evict the data, but the data is still managed in Greenplum. But if your agents or your clients, if they ask GemFire for a data set like a news sentiment, and maybe it's a historical news sentiment that's not in memory, it can hydrate that information from Greenplum back into memory. So that's some of the ideas on how you can manage, even if it's a massive amounts of data, you could still scale GemFire, but you also augment it using some of its out-of-the-box connector capabilities with something like Greenplum.